Hello everyone, and welcome to another Godot VR tutorial. Apologies for not posting anything sooner. I spent some time enhancing the OpenVR plugin, and due to the COVID-19 pandemic, I've been busier than usual at my day job. I hope everyone is safe and doing well. I'm also nearing 4,000 subscribers here on YouTube, which is just amazing. Thank you all for your support. I originally wanted to do a video on throwing objects as part of the VR weapons tutorial, but have decided to handle this subject in a broader context. This video is an introduction into that series. I'm not going through the entire build process of this. Instead, we'll do a quick review of how things are put together. I'm also using my Oculus Rift S with the Oculus SDK plugin for Godot. I'm really enjoying the Rift S as a development platform, as due to its design, it is a headset that is comfortable to constantly take off and put back on. Finally, everything shown here is built using the latest Godot 3.2 release, and I highly recommend using that version if you're following along. I've only kept our main scene in the root of our project and created subfolders to divide the project in logical pieces. First, we'll quickly look at our add-ons folder. In here we find our Oculus add-on that allows us to use the Rift and Rift S headsets. And we find our Godot XR Tools add-on. This used to be called the VR Common Library, but we recently renamed it. We rely on this library a lot in this series. Note that for both add-ons, we're using the latest master builds. You'll want to use those if you want to follow along. Next is our Assets folder. In this folder, I've placed all assets I've downloaded from third parties. We'll make a lot of use of PBR textures downloaded from cc0textures.com. I've included a font that we'll be using later on in the series to render some text to screen. Our background HDRI is from hdrhaven.com. I've also included 2 asset packs from Kenny.nl. If you haven't already heard about Kenny.nl, this website provides brilliant royalty-free low-poly assets you can use for your projects. Note that I've only included the GLTF files to save space in the repository. Finally, there are a few prototype textures from Wahuni that I've been using a lot lately, though these are currently unused in this project. Then at the top we find a folder called Models. I probably should have found a better name for this. In this folder we find all our subscenes and scripts that make our project work. I'm trying to leave our assets folder as unmodified from the downloaded originals as possible, so all our own work goes into the molds folder. We find a folder called Kenny.nl in which I've placed scenes that utilize Kenny's assets. We find a miscellaneous folder in which I place stuff I can't find a better name for. We find a folder called Room Parts that contains a number of scenes that form the primitives that make up all the rooms, so walls, floors, door frames, etc. And we find a folder called Rooms that contains subscenes for each of the rooms that make up our house. Looking at our main scene, we just find our overarching structure. There is a directional light here that is currently turned off. I've gone for a night scene to allow for some nice indoor lighting, but sometimes it's handy to turn a light on to make it easier to edit stuff. Next we find our Oculus First Person node. This is a subscene that is present in our Oculus add-on. You can see in the add-on folder we have a bunch of handy scenes here that get you up and running with the Oculus Rift. Looking at our first person scene, we find all the basic elements that Godot needs for a VR project to work, including the code to enable the headset. It even comes with some Oculus touch meshes to visualize the location of our hands. We will be replacing this with a more generic implementation in the long run, but for now this gives us a head start. If you want to follow along with OpenVR, the OpenVR plugin has a similar scene you can drop in. Back in our main scene, we can see that Editable Children is turned on for this subscene, allowing us to add additional things into this part of the scene tree. We can see that our shader cache from our Godot XR Tools add-on has been added. I have a nice video explaining what this does that I'll link in the description. We also find function subscenes that have been added to the controller nodes. These are subscenes that come from our Godot XR Tools add-on that implement basic VR-related features. We see on our left hand that there is a function that allows us to teleport around our scene using the trigger button on our left controller. Note that Editable Children is turned on for this as well, so I can hide the capsule. There is also a function that allows us to pick things up with our left hand. We'll revisit this later on in this video. This function has also been added to our right controller. On our right hand, we find a direct movement function that allows us to use the joystick on our right controller to move around our home. Currently, I have enabled smooth rotation, which can cause motion sickness in some people. We'll address that later on in the series. Then looking at our house itself, we'll see that all our rooms have their own subscenes. This is a nice way to organize things. We can work on one room at a time by editing the subscene. There is one scene that contains all the elements that are on the outside of our house. These are purely there for decoration. As the player will never be able to go outside, we're only placing things that can be viewed from the windows. Also of note is our bathroom, where I've used our mirror trick. If you want to learn more about the mirror trick, see my Smoke and Mirrors episode I did on this subject. There are two cameras here that render to textures to close off our doorway and the view through the outside window where the illusion would otherwise break. The scenes for our hallway, living room and 2 bedrooms are all built in the same way. We'll have a look at our living room for this. Note that I've hidden the ceiling in every room to provide easy access to what is inside of the room. The ceiling is made visible by a script on the root node of each room when our project starts. The room itself is put together with very simple assets, all organized in a few nodes. Looking at our floor node, we see all the floor elements placed there. Each is a subscene we can find in our room parts folder. In our 2x2 floor panel subscene, we find a simple static body as our root. There is a mesh instance with a flat cube mesh. Note that no texture is applied. And there is a collision shape using a box shape. Each of these subscenes have a simple script applied that allows us to set the texture used. This allows us to reuse the same floor panels, but with different textures in different rooms. We can see here that we're using a different material in the kitchen part of our living room and the main part of our living room. Godot will very efficiently reuse all the assets. The walls work exactly the same, only here we've got an exact fitting collision shape for our wall segment. Note that I use box shapes as my collision shapes almost exclusively, as they perform a lot better than mesh-based collision shapes. I also have some basic scenes for our windows, but there isn't much to tell here. The wall segments that have a space cut out for our windows do have full collision shapes, so there is no point in also creating collision shape for the windows. All the other assets in our room all come from Kenny.nl. Looking at Kenny's assets, the really cool thing about using the GLTF format is that Godot will create material files for all materials found in the assets. Once created, these material files won't be overwritten, so we can change them and quickly dress up our assets. So when we open our carpet material that I haven't configured yet, we see a very simple colored material that these assets come with. But we can quickly assign our PBR textures to these materials and immediately make the assets look amazing. Our wood material here is set up with a really nice wood texture, a roughness map, and a normal map. I've left out the depth and ambient occlusion maps. In my opinion, they don't add enough to justify the extra work the GPU needs to do. Finally, to complete our setup, we need to go into project settings and go to our physics layer setup. Here we can see that I've defined a number of layers. All our objects are placed in the correct layers, and for all our kinematic bodies, rigid bodies, and areas, I've set my collision masks properly as well. We'll see how this works when configuring new things in a minute. There are already a number of objects in our house that we can interact with. To show how to put these things together, we're going to add some more. To be precise, we're going to build a little dart throwing game. As you can see, I've downloaded some more assets, this time from free3d.com. We have a dartboard and a dart that we'll use. Let's start with our dartboard, and we'll create a new 3D scene for this. I'm going to change the type of our root node to area. We only want to detect when a dart hits our board, and as we've learned in my Godot physics tutorial, areas are ideal for that purpose. We'll rename our root node to dartboard, and we'll save that into a new folder I created called Objects. We'll add a mesh instance to our scene, and we'll drag our dartboard object into the mesh slot. We can see that our dartboard is huge. We'll quickly add our subscene to our living room. We add it to our misc node. We can see that this is totally the wrong scale. Instead of scaling our mesh instance, we'll select our object file and then select the Import tab. Here we'll change the scale at which we import our OBJ file and then select Re-import. Now, one thing of note that a lot of people complain about, very often OBJ files do not import textures from their material files. We can see that here this worked fine. There can be two issues here. The first is simply the material file containing paths Godot doesn't have access to, but here the texture files are in the same folder as the OBJ file. The second issue is when the OBJ file is imported before the texture file has been imported. This actually happened for me here. Simply re-importing the OBJ file fixes this. In preparing this video, I had already re-imported the OBJ file, hence it seemingly worked the first time. Next, we need to add our collision shape, and this is pretty straightforward. Add our collision shape node, and then add a cylinder shape. We do need to rotate our collision shape, and then resize the shape to fit our dartboard. We also need to set the collision mark for our area. Note I'm setting the layer here, but for an area it is the mask that is important. We'll have to rectify that later on. As we want to react to our darts, we'll want to set our mask to darts in due time. Going back to our living room, we'll move our dartboard into place. We'll move it nicely up the wall. We don't want it too high or we'll hit the ceiling with our darts. Next, we want to have a little table on which we can put our darts, so we don't need to pick them off the floor. We'll create another new 3D scene. We'll change the type here to a static body. We'll look in our Kenny.nl assets for our table round asset and drag that on top of our root node. We'll rename our root node to table round as well, and then save it into our Kenny.nl folder inside of our models folder. I do need our table to be higher than it is, so we're going to scale it on one axis. In this case, we'll do that directly on our imported node. Now we want to move our table so it is standing on our floor and centered on our origin. We also need a collision shape. As this is a static body, all we care about is a collision shape for the top of the table. So we'll use a cylinder shape. It's not a perfect fit, but I prefer primitive shapes over tri-mesh shapes due to their efficiency. We'll go ahead and add that into our living room and move it into place. One last thing we need to change for our table is our collision layer. We'll go back to our table scene and change our collision layer to the environment layer. And as our collision mask isn't relevant here, we'll turn that off. Now it's time to create our dart, but here we are going to create a new inherited scene. We navigate to our Godot XR Tools add-on into the Objects subfolder, and we choose the interestingly named Object Pickable scene. This scene contains all the logic that allows our object to be picked up by our pickup function. We'll rename our root node to Dart. Now we add in a mesh instance node and drag our Dart OBJ into our mesh slot. we again have an object that is huge. We solve this the same way as with our dartboard, changing the scale and re-importing the asset. In this case, I chose a scale of 0.02. That is slightly larger than it should be, but it makes it easier to pick up the darts. Let's save our scene at this point. We'll put it in our Models Objects folder. I'm going to temporarily edit my default environment and put my ambient light energy way up so we can more easily see our dart. Our dart is centered on the tip, but for our physics engine, our origin will act as our center of gravity. We want to center our dart, but before we do this, we'll add a spatial node as a child so we can find the tip of our dart later on. We'll call this point. Next, we'll create our collision shape so we can use this as a guide for centering our dart. However, I am going to use a box shape here. Our physics engine doesn't simulate how aerodynamic our dart is, and the box shape will prevent our dart from rolling away from us. Trust me, I've had them go all over the place. Now we move our dart into place. I eyed the size of the collision shape pretty good. We do need to change the width of our collision shape. Next, I want to rotate the dart so it will seem to rest on the wings when it is put down. As such, we need to adjust our collision shape a little more. When we pick up our dart, by default it will be attached to our controller based on its origin. But that is not where we want to grab it. To solve this, we simply add one more spatial. We call this Pickup, and move it into place. Finally, we select our root node and check a few settings. We leave our press to hold setting set. This allows us to throw our object by letting go of our grip button. We also leave our preset transform set. This snaps our object to our controller. Then we assign our pickup node to our center pickup property. Then we select our dart's mesh instance as our highlight mesh. This will change the color of our dart when our controller is near enough to pick it up. Our pickup layer is less important right now. This is the layer our object is temporarily moved to while it is picked up. We'll assign layer 11 to this. For our standard layers, we want to change our collision layer to the dart layer. And we leave our mask on the environment and pickable objects. Do note that we should select darts here as well, and I'll fix that off camera. Let's quickly change our ambient light back to normal. And now we'll add our dart into our scene. We'll rename that to Dart01 so we can add some more. And we move it into position. Now we'll duplicate our dart to create a second dart and move it into position. However, we now have a problem. If we hover over our center pickup on and highlight properties, we'll see that our second dart is linked to the first dart's nodes. We can rectify this by simply clicking on the reset buttons on our properties. Now we see that they are linked to the second dart's nodes. Pretty annoying problem, but luckily easy to fix. We'll add some more darts, move them into place, and fix up their properties. Let's test our project. What the? Why are all my darts on the floor? Picking up my darts, we see one fall through the table, and the other starts dancing around like crazy. What is going on? We can throw them all right enough. The first problem is easy to solve. Our dart is simply falling fast enough that it misses the collision shape of the table. We can turn on a setting on our dart called Continuous Collision Detection. This checks the entire path our dart moves along at the cost of performance. Important for small objects, generally less of a problem for large objects. The second problem is more annoying. We're not sure if this is an issue with cylinder shapes or if this is a problem because of the scale that we're working at. The Bullet physics engine isn't configured to handle small objects very well. Its default margins are set to 4 cm, and we're dealing with a dart whose radius is much smaller. I'll be doing more testing with this, but for now we're going to work around it. Box shapes and tri-mesh shapes don't seem to have this issue. We'll use a tri-mesh shape and we'll let Godot create it for us. We'll turn Editable Children on for our Assets node, and select the Mesh Instance node within. Now we get an option in the toolbar to create a collision sibling. We'll choose the Single Convex Collision Sibling option. This creates a convex volume within which our object fits. We have, however, a problem because our mesh instance was scaled and our collision shape is on the wrong node. So first we'll copy our collision shape into the correct node. Then we turn Editable Children off. We'll save it and reopen our scene. Now we can see that we just have our collision shape, however it is not the right height. We don't care, as we're only interested in the top of our table. All we need to do is move our collision shape into place. For our third problem, we go back to our main scene and select our Pickup function node. Here we increase our impulse factor. This simply gives any object we throw a little bit of a boost. It's cheating, but it works. Make sure to do this on both hands. As you can see, we can now play around with our darts without them going all over the place. That's where I want to leave it today. We'll continue this series soon and react on the darts hitting our dartboard. Later on, we'll start looking at other interactions as well, such as opening doors, breaking stuff, nicer hand interactions and such. This project is on GitHub. It already has some experimentation in it for things I haven't covered and may change. Please leave a like if you found this video useful and consider subscribing if you haven't already. If you like what I do, you can support me more directly on Patreon. As you can see, I list all my patrons at the end of each video. Until next time.